My name's Neil Cameron. I'm field engineer for PMC. I'm field engineer for Adaptec by PMC for the Asia Pacific region. So what I'm going to talk about here is what we call max cache. It is the utilisation of the memory within an SSD drive as read cache for a RAID card. Right. So the basic fundamental reason we do this is to improve random read speed from spinning drives. Spinning drives will do sequential data perfectly well, reads and writes, no problems. We can do random writes by caching the writes into the memory on the card and then writing them down in a fairly sequential manner. So we've got that covered. A random read, on the other hand, we're waiting for the drive to come around and give us that data. So the latency of the drive is a killer for us. So if you just like to turn the camera this way and have a look, we have here a standard RAID array that is made up of spinning disks of either SAS or SATA drives. We have one of our Adaptec RAID cards and we have a solid state drive. Now the solid state drive to you looks like a hard drive, to me looks like a chunk of memory I can add to the card. Now customers will talk about, could we go from 512 meg to maybe 1 gig of cache here? Why not go 32, 64, 256, even up to 2 terabytes of cache?
Wow.
That's numbers that can never be achieved on a hard drive, or sorry, on a card. The fundamental process is that the card learns the behavior patterns of the data, so it watches the data go from the hard drive across to the user. When the card sees blocks of data, and we're talking blocks, not files or records, but actual blocks of data. When we see what we regard as hot data, so frequently used, commonly random, so only not associated with a large chunk of other data, in the background we'll copy onto the SSD. And the key word there is copy, because we never put the data at risk. Unlike a write cache, we want to make sure that we don't lose it, so it copies it onto there. The next time that that block of data is requested, if the block of data lives within the DDR on the card, it'll come from there first, standard caching practices. It will then look in the SSD for that block of data, and if it's deliverable from there, it'll come at very high IOPS performance that the SSD can deliver the solid that the hard drive can't. If, of course, it's not on there, it will go and get it from the spinning drives. The end results is anywhere up to 8x performance. So I have on the screen here, I have a demo system. I'll just minimize this for the moment. I'll bring this up. I have here a RAID 1 made on 2 spinning SATA drives, the 500 gig WDs. Now, a RAID 1 is not a particularly fast device because it's only 2 drives. On that, I'm running a demonstration which is, I'll bring this down here, this is a small web server script running on iometer to show intensive random reads. Our 2 key figures here are the IOPS, or total IOs per second, which are running around the 10 to 12,000 mark, or sorry, 1,000, and megabytes per second running anywhere around the 15 to 18. You'll see that on the front of the server here, there are 2 drives that the LEDs are on, so if you want to back up a second, you can see on the front here, these 2 drives are part of the mirror, or they are the mirror, and so they're being heavily used. Sitting across here is an SSD that's dedicated as cache. If we can slip back to the screen for the moment, you'll see that I have on this controller 2 spinning hard drives, an SSD, which I'm using just as an SSD, and then this 4th SSD being a 30 gig Intel X25, it says cache. I have enabled that into the cache pool. So now that is not a drive as far as anyone's concerned, that is now memory attached to the RAID card. On the RAID array, I can enable and disable the max cache function. So when I turn this on, it's going to start learning the data block patterns that iometer's doing. And take this with a grain of salt. This is a compressed demo for demo purposes. This would, on a heavily loaded system, would take about 4 hours. We don't have 4 hours and the battery won't last that long, so let's go. I'm going to, so just to reiterate, we're doing 1000, 1100, about 14 to 15 megabytes per second. Once I enable Max Cache, come up here, configure Max Cache and enable. I'll go back to this screen and immediately we see a very small dip, and that's just while it configures itself. So already we're back at our previous performance levels, and over the next minute or so, a couple of minutes, we'll see the numbers start to increase. What's happening here is the card is learning the data patterns, it's copying into the background on the SSD, and then it's starting to read those blocks of data from the SSD. Just like to step back a second, you'll see the front of the machine. There's a third light on now. This is the SSD coming into play, acting as cache for the card. So I've still got my 2 drives from the mirror still working hard. Now the cache is adding to that. And if you look up at our numbers, while we were magically away elsewhere, you'll see we've hit about the 260, 270 megasecond mark, and our IOPS have jumped from 1,000, 1,200 up to about 16 to 17,000. Now this is a demonstration, and I'm not going to say that the end user is going to get that dramatic a jump in performance, but we will claim between 500 and 800% improvement. And they're numbers that people just, they don't believe. You've got to see this to believe it. So it works in the right environment. Like any kind of storage, like any kind of RAID configuration, you have to configure your system to suit your data, not just build X, Y, Z and hope it'll work. This technology is aimed at highly intensive random read environments. That would be web server, terminal server, VMware, database, even file server, because the majority of file servers read. So any of those environments, this benefits greatly. Video capture, no use whatsoever. Don't even think about it because it doesn't impact on rights whatsoever. It's a safe, cheap, fast technology that allows you to get massive performance out of a big system without you having to discreetly put the data in different places. The card manages the flow. And that, ladies and gentlemen, is Max Cache by Adaptec.
Thanks so much for taking the time to talk to us.
Sorry?
Thanks so much for taking the time.
No worries. Thank you. Great to talk to you.